Hello, hello, hello. No, yes.
Huh?
Hello, hello, hello. Yeah.
That's the red microphone. The Lumens is the red microphone.
This.
Yeah. It works quite well, but you have to stay not too.
I hope now it's working. Yeah. Sorry, everybody. Okay, so go on again. No, it's
back. It's back.
it's back. Okay. So why first, but try to give you an idea why this can be important for us, even though that is probably created for computer scientists and software engineering. So we have with GitHub free version control, which means we can keep track of every change of we're doing, not only for code, but for any files, documentation, or anything we want to keep track. Keeping track also means keeping the information who did the changes and when, so we can roll back and recover what was before. So we can create community because we can share this with the with the community very easily, which means they can reproduce our work immediately without us trying to find the files or the information and send them back on an email. So we can create documentation using GitHub. So everything you create, you have a wiki area. You can create a documentation. You can easily back up everything online. So doesn't matter if you did a work 10 years ago, if this is in GitHub, it will be there, and probably you will lose some hard drives, but in GitHub, you keep the data. And well, because you are sharing the research openly, it's great for open science. So I'm gonna divide the presentation first, talking a little bit about Git and GitHub, how we can set up GitHub, what is a repository, and the different kind of repository we can find. Then what is the workflow? So how we can properly work with GitHub. What happens when we make some changes, some of the best practices, and then I'm going to try to present online some of the things. So Git was created in 2005. Something you can install locally. Is for keeping version control. Is working a distribution. It's a distributed system. That means you have a main repository. You, as a user, download that and make a copy, and you work in the copy, and everything in the team work in a different local copy, and then they merge all together in the same main branch or repository. On top of Git exist several services that offers more features and try to power up a little bit what is Git. So probably the most common one is GitHub, and I will focus on GitHub. And they create this collaboration space, so you can create issues, which means you can submit some comments to the owner of the repository that something is wrong, some discussions you can create there. So you can have ways to continue integration. So if you have some ideas or something to implement and to add value to what is in one repository, you can submit that changes, and the owner of the people with the rights for that can review before merging and do the changes. So that keeps everything safe and keeps the information of which we call it the blame, who made the changes. So as I said, Git, you can download it, sits for it, doesn't matter which operation system you use. There's a couple of configurations you can do immediately in Git. So you can save it, which is the username and the email. These are important because this is how you sign all your changes. So if you add this, your changes will be signed with this information so people can see you did it. And it's yours to blame and yours to thank. Well, as I said, we have more than one system. GitLab and Bitbucket probably are the second and third in the most popularity one. But with GitHub, you can have unlimited private and public repositories. That wasn't always in that way. So first they are all public in the free account. Now you can have private, which is great. When you create your account, here is a little bit of advice. Try to be consistent with the email you will use. So you can use your email from your institution, but if you're thinking that sometimes in the future you will be moving from that institution, you will lose access to that account. Not necessarily lost access to the information there if it's a public repository, but if you have an email where you're known in the community, I will create the account with that email. So you can connect your papers and the emails you have in the papers with the GitHub account, so it's easy to find you and find anything you're sharing there. As well, the username. So for example, in my case, the email is my personal email, and the account is my name, basically. So it's really easy to find me. This is a small view when you have several repositories. In the you have a profile area. So in your profile, you have different cards that showing the main language and the name of the repositories. So I will show that later in the live demo. And when you create a repository, you obviously have the owner. You have the option to change the owner if you have access to an account as an institution, or you can have access to other accounts. So in this place, you can that the name of the repository. So you have to be. It's better if it's a very sensible name, easy to connect with the idea you're working in it. Here, doesn't matter if that name exists in another person environment, as long as it's not in your environment. So under my name, Dabike, I can have one, so I can repeat the names, but two different persons can have the same name in the repository. The description is optional, but very important. Here you can decide is it public or private. You can change this later if you want to start working on something and then make it public. And there's 3 files that may be important, depends of the focus of the repository, which is the README, the git ignore, and the license. These files, the README is a markdown file that is the first view of what is loaded when you open a repository. So everything that should ideally describe what's the repository about. The license, here you can add what kind of license have the content in your repository. And the git ignore is a file that saves every kind of files that should, the information of the files that should be ignored when you save something into a repository, like compile files or temporary files. You don't want or you don't need to save them in the repository because they are not important for the content. So you can add that extension or the directory in that git ignore. I can show you later how you can generate those. It's really simple. There are a lot of tools for that. So there's some special repositories. One is the profile. So when you create your account, you can, these are not repository created by default, but you can create a repository using the same user account as the name of the repository. So in my case, as you can see, that repository is called Dabike, as the name of my account. That repository, when you go to the profile page, is saving what you can show there. So basically, it is the right part of the screen. So the header and the content there. So you can add there in that place whatever you need. If it's more like a project repository account that you created, you can add there the description of the project, and you can have several repositories for the same project. And you have a special repository also for our website. This one is, you have to create it with your name, your account name, .github.io, and that will be after compiling some of the files, which is a markdown website, and they have some templates, so you can easily create one using the templates. And you have a special website easily to implement a static website. So you don't need to pay for any other service to have this static website. But let's start with some of information, how is the workflow when you're working in a repository. So in this diagram, I'm trying to show there's two ways you can work in a GitHub. If you are the owner or part of the repository, which is the top part, so you have access directly to the original repository, or you want to collaborate with a repository that belongs for a third person, so you don't have write access to that repository. That is the below part. As you can see, the only difference is when you're external collaboration, you need to what is called fork the repository. When you fork the repository, you create a copy of that repository under your account. So then you can work on that because you will be working your account, and then you can submit the changes to the original repository. So the workflow goes, you have access to the repository, whether it's a fork or the original. You do the clone, which is making the copy to your local environment. So from GitHub to your computer. So you clone the repository. Then we use, or we create branches. So GitHub works with the idea of branches. So you have the main branch, which is the main code. And then when you want to do some changes, in order to avoid alter or make something that disturb what is the main code that it was already tested, that is already working, you create a branch, which is a copy of that. You develop in that branch without affecting the main branch. And when the changes are okay for you to add to the main branch, you can merge the branches. So in the local repository, you create a branch, you make the changes, and you save it by committing the changes. When you commit the changes, you have the option to submit a pull request, which is when you ask the owner of the repository to accept or to review and accept your changes. I know there's a lot of terms and process, but if you think about it, it's a really simple process. When you clone the repository just once you have cloned it, every time you want to make a change, the safer way is to create a branch, and you work in that branch, which is a copy of the main. After you you finish the changes in the branch, and you feel safe about it, you can merge it to the main repository through a pull request. That is, in general terms, the whole workflow. So there's two ways of really easy to clone the repository. Each repository in GitHub has a button on the top right, which is called clone, and it says clone, and it will copy a URL. And then in your computer, you just need to type in a terminal, git clone and the name of the repository. And that will download the repository, as you can see again in the image. So that is one repository. I copy the link from that clone button, then open the terminal. You just type git clone and the URL, and that will be automatically download the repository. It created a directory, and in that directory you will find all the files that were online. So every time you work in a branch, this is part of the beauty. If you create new files and stuff, every time you change the branch you're working, the files you're seeing in that directory will change according to the branch. So GitHub will be keeping track of all that changes. So, okay, we clone the repository, so we have the copies, and now we have the branches. This kind sounds a lot of commands, but you can do it online. But as was explaining before, so we have the main branch in the top figure. So if you want to work in one feature, I don't know, yeah, you can branch into feature one and do the changes, and then pull request or PR the changes into the main, and that branch can be deleted, the feature one. You can also open a branch from a branch. So if you're working in feature one in your code, and then on your files, and then you want to add a feature two that is related with the feature one before added to the main, you can clone a branch from the feature one, PR to feature one, and then PR to main. And that feature one, feature two, after merging with the main, you can delete them. So if you want to branch using command line, so you first call git checkout -b and the name of the branch. And the second command, the git push -u origin and the name of the branch. So the first one will create a branch locally, and the second one take that branch and copy it to GitHub or to online. So you have that branch in both places. And when you have both branches created, so when you have a branch created, you can move between branches using git checkout and the name of the branch. That command is the one that moves you from branch to branch. Yeah.
If you're working on a branch of a public repository, can other people look at the repository, see your branch?
Yes. When you're online, so there's a list of the branch, and you can just simply add the name of the new branch. So if you can search there, if the branch doesn't exist, it will create a branch using that name. So probably that online, it will be simpler, and I can show you later. But then you need to, and you can locally then check out to that branch. So after we finish any change in the branch, we do the pull request. So this is a little, so the interface, the pull request is online. So the first two steps, you need to do it locally. But when you finish and you submitted all the changes, the pull request is an online step. And that is the screen, basically. And it's showing this branch is merging into this branch. These are all the commits or the changes you did. And then you press create pull request. And that will create a request that somebody can review before merging. As I said, in GitHub you can add issues, which is a way to have discussions about bugs, improvement, or ideas within a repository. It's just the interface is you create a title for that issue, so people can see it after that. What was in the discussion, you can write what you want and start sending the messages, and you will have like a forum basically. Here in the making changes, so well, we have the branches, well, we have the main, we have the branches, and we want to work in one branch. So if you can create a new file, and to add, when you need to save the files, there's two stages. First, we stage the changes, and then we commit the state. When we stage the changes, we move these changes to a temporary area before submit it and to save it. And then we commit it, which is added a comment and properly save them. So git add name of the file is just added to the stage area, and then you git commit -m and add a comment so people know what is in that commit. And git push, we submit it to GitHub. There's different parameters or ways to call a git add, which is with a dot. So well, with the name of the file, with a dot, or with -i, which open up a list. I can see some people, yes. This is when you're working in their terminal. Many of the GUI or system for programming, probably Visual Code, IntelliJ, others, do a lot of this step automatically, but they still need to branch and create a branch if you want to, need to push and commit. And when you commit, they usually will ask you for the comment and do all this git add and git commit for you. But I think it's important to note what is happening when you do it. When the git commit, you have to add a comment. This comment is really important because it's helped later to understand what changes were done at that time. And if the file is not new, so it was already added at some point in the stage area, you can call git-a-m and the comment, and it will do the stage and the comment and the commit immediately. So to understand the commits, if I create a new file and I need to add it to the repository, I git add this file and then git commit adding, so created file something as a comment. Then you can add some changes to the file. So you can add now, you can call git commit -m. I change new something, whatever you did. Then you regret it. Okay, and you delete it. You can add a new commit, I delete this. And all this commit will keep track all the changes. So you have a history of what's happening in the repository. And then after you change all the commits, can be several commits, you can push. And that's simple local, all these changes, move all these changes and copy it to the GitHub repository. Because there's a lot of things that can go wrong, or one can lose control, there's a lot of a couple of commands that can help to keep track of what's happening with the commits. One is git status. So this is an output where it's showing me that I modify read the README MD file. That is change to be committed. So I need to commit this change, and it's not a stack. So I need to do the add and then the commit to that file. In case, if you have more files, you will see a longer list, obviously. Another useful command is git log. Git log shows a chronologically descending list of the commits. In this case, in the picture, I call git log -- graph. So it's showing the branches lines, basically. So this commit was in one branch and then was merged here. So you can see where that changes or where there are commits or to what branch they belong. So you can see what happened at each stage descendingly. This is important because it also gives you the hash value of your commit. That is so the unique identifier of that commit. And that is important if you want to undo something later. So here is a better view of the image. So you can see, now it changes. So the author, when was done, and the comment. So this is, I generated some data sets. This means I merged that into the remote tracking to the original or main branch. And then there was some training or something there. As you can see, all these commits have an author, so I know I did those. So I am to blame about this. There are 3 commands you can use for undoing stuff. Each have slightly different purpose, but I don't recommend using all. So especially git reset, this is the most dangerous one, because you can rewrite the whole history of the commits, and then you lose. There's no point to lose the history. Otherwise, what is the point of version control? The git checkout probably can be confusing at this point because it was used to create a branch and to move between branches. But if you have a file you want to come back to a previous stage, you can do the git checkout and the name of that file. It will return that file to some stage, at the previous stage, basically. So that's a way to recover a file before it's committed. If you have a commit, you commit some changes and then you regret those changes and you want to come back, with the previous command with the log and the status, you can have the hash value of that commit and you can do a git revert and that value. The git commit revert, what we'll do, we'll return the files that were altered in that commit to the previous state, but adding a new commit, doing those changes, or removing those changes. So we'll return your files to the stage before of the commit by creating a new commit with those changes, basically. That, I will say, is the most safer way to do it, because you will also have a record of you reverted that file to that state. So you have both, the one you regretted and the new and the safer state. So if you need to check later, you will have that history. So in the best practices, every time we are working in a branch, the first thing you should be doing is always git fetch origin, which is reading from the online repository and bringing a copy of reading that and having a history of what is done that you don't have, then you can git merge, which is basically taking all those changes and merging in your local repository. Or you can do a git pull, which is doing the same, both stages. This is safe, especially if you are in a team, because if somebody else do some changes and you are doing another change, probably in the same file, different parts, but if then you don't, and the other person is pushing and submitting all the changes, and you don't get those changes, at some point you can start editing the same area, and it does. At that point, it's very, very messy because you need to start deciding which of the both version is the one you want to keep. So it's always safer just pull the changes constantly before you're saving the changes, so you can know if there's some things that can complicate things later. Always finish the day by committing, or you're working by committing and pushing the changes. This is important for the same reason. Well, one, to avoid losing something, and so if there's other people working on the same project, on the same files, know your changes and have the last version. So the commits, keep it simple. So you don't, if you need to revert something, you don't revert a lot of stuff, so you can keep it simple. And frequently, but needs to be smart. So you don't need to commit every single small changes, but if you do some new function or something, or you needed to alter some function, some metric you implemented, and added some conditions, some flags, okay, everything related with that flags, it can be in one commit. So you have both versions in the history. So not sure, yeah. Let's try to do something. Okay, so we're getting time. Let me, where are you? So this is my profile view. So as I show you, this is where this repository with my name, or with my account name, this is the information it has in that. So inside you have a README file, a README MD, and the content is read it in this way. So here is a pencil, so you can see what is in there. It's basically a markdown content. And these are 3 services I can show you later that shows this information, so you can show off a little bit. But we can, so for example, in this case, we can alter this small file that doesn't need to, I don't need to clone the repository to make a small changes. So here I can say, so I did the change. In the same logic, we need to commit the changes. So the message basically is I updated the README, and I want to commit it directly to the main branch. This is when you want to edit something online, simple, like in a text file. So as you can see here, it's showing me we are in the README file, which is then loaded in my profile. let's create a new repository. So in the profile, you have the overview, which is what is loaded with this special repository. You have a list of your repositories, some projects you have one. So the project you start, so you can start some projects. So basically, instead of liking, you start the repository. This is a view of my repositories. I don't know how it works. Yeah. So as you can see, for example, this one is not mine originally, but it's forked from its mirror datasets. So if I enter this repository by the blue name, and I am under my account, so it's me and the repository, and it's showing me that this branch has 2 commits ahead of this. That means I did some changes that are not in the original repository. And here you have a small link that will redirect me to the smear and the original repository, basically. This is a case where I did some changes and submitted a PR to the original. So I made the changes here. This is why I have 2 committed. Then I have to go to this repository, go to pull request, and say, so from my account to smear, I want to merge 2 commits. What can they do now? So obviously I added some comments. They can go to the commits. So this is the 2 commits I did. And they can check the files. So both are in the same file. So I deleted 1 line and added 1 line. So basically every time you edit 1 line, the review shows you deleted and added. So you can see it was an addition because it's basically the same line. Here I deleted 1 line and added all this content and then submitted the PR. So now it's to them review and check. So I can see somebody liked it. I can see who. And I did it 3 weeks ago. Let's come back to my account. So as I show you, we can create a new repository. And this repository, we can call it test. We can add some comments. We can make it public or private. We can add a README, what will be blank. We can add a basic Git ignore. Let's say we are going to work in Python. We can add some license. Let's say it will be Apache 2. We create the repository. And that was all the steps to creating the repository. Because I checked these 3 files, they're already created there. So now everybody can check the license. We have the README. So I'm not sure if it's worth to go to the command line. But now if I want to work this locally, let me share better the whole screen. Yeah. So we said we want to clone it. So here it says code. We have an URL. This is basically, and we can copy it just clicking here. You can download it as a zip file if you want, but that not allows you to work locally, or to do the whole process. And then we can, where is it? Yeah. Here, in any directory, doesn't matter. So we can git clone. Oh. Run process. Doesn't want to copy. And paste. So copy it. There you are. So now in my directory in C, I should have this test directory. Yeah. So I downloaded these 3 files. So we can go into test. We can now create a directory. And inside the directory, a file. So we said we have some files we can, some commands we can run. So in git status is showing me we have a directory which is untracked, so we haven't tagged it yet. And it's saying, well, use git add, okay? What it's saying now is saying we have stacked the directory, so that include the files we had inside. So because we already did the git add, we can do git commit. We commit the file, so it's saying we have a new file change, no insertions, no deletions, that means unlines. And we can submit it to, it's not a spelling proof. Okay. Yeah. You're going to, forgot my password is not that simple. Just send us it. Authentication file, yes, super. Yeah, it doesn't like me today. Let's try, otherwise it doesn't matter. What is this thing? Yeah, I don't know what I'm copying, but that will basically move the stuff here. Here we have the issues. So for example, in the issue, we can say, so we can say we want the feature, we submit the issue. That allows us to start a discussion about it. And if we in the discussion say, yes, interesting, we can create a branch directly from here. So we press the branch. It will be named, well, you will have a number, a correlative number, or increasingly number. So this is the first branch we create, so it started with 1. And create branch. So here is just sharing what are the commands you need to run locally to download the branch. If we go to code, we have here a list of the branches. Now we have this first branch created here, or we can so it doesn't exist, so we can create a branch. Now we have 3 branches. Here inside the directory, Git, well, we can set Git pull. So it's saying there's 2 new branches when we pull it now. And we can start working on those with Git checkout test2, for example, is capital T. So it says I'm moved to the test2 if I call Git branch. This is just a list of the branches showing me in green or with a star where I'm located. So I'm gonna stop the demo there because no, I'm not sharing what I want. Just because of the time, but before finishing, there are some resources you can use. So for the profile, there's several, I like this one. Online systems, you can add your information and they will create the markdown content you can copy inside your, or in your README file. You can create a Git ignore, more advanced one. If you're having MATLAB or other content inside, you can add it. And we'll create a list of the files you need to ignore, a very comprehensive list. And we have, I already did some talk before. It's a little bit different. I did it with Jupyter books, which is basically several Jupyter notebooks that are compiled into a website for the BCCA. So this one, probably not sure, but you can have access to that as well. Okay, I hope that was kind of clear. I know it was a lot of information. I left a lot out that is not really crucial for starting. So I don't know if there's any question. I saw a lot of comments going through the chat.